Okay, just a couple of reminders. Remember that your natural numbers are your counting numbers, okay? So especially if you were absent on Monday or you didn't write this down, this is posted on Canvas, okay? You guys are gonna get to use anything you have in your notes on the test next week. So this could be super, super helpful if you have this in your notes. You get to use it on the test. Okay, so starting down at the bottom, remember natural numbers are all your counting numbers. Okay, 1, 2, 3, 4, 5. That's kind of how we started counting. Remember that natural numbers cannot be negative, and there's no fractions or decimals. So any of those things you want to add to your sheet of paper, you can. Okay. Then if we move up the list, the next one is a whole number. Whole numbers are all of our natural numbers, including 0. Okay. So it's 0, 1, 2, 3, 4, and so on. Again, no fractions or decimals and no negatives. So whole numbers and natural numbers are really nice numbers because they don't have negatives. They don't have decimals. They don't have fractions. They're just really nice. Integers are all of our positive and negative whole numbers. Okay, again, no fractions or decimals, but they can be negative now. Okay, and then we get to rational numbers, and rational numbers are any number that can be written as a fraction. Now, I want to remind you guys, the way that this chart is set up, a number can be either rational or it can be irrational. Okay, kind of like how sometimes you guys can be rational or irrational. Okay, or maybe you have a sibling or a parent that sometimes acts irrational. I hate to admit it, but sometimes I'm irrational. Okay, like when my kids are really, really, really driving me nuts, and I'm sure you guys never, ever do that to your parents. You are perfect angels all the time and never drive them crazy. However, that is not the case in my house. And I will say, well, Riley, sometimes it's you, but a lot of times it's the younger ones. Okay, and when they really, really, really are driving me nuts, then I lose it. And I maybe act a little bit irrational. Okay, now I typically come back to being a rational person later. But or if you have a younger sibling that they get mad about something and they just you can't even talk to them. They're just on a whole new level. Okay, maybe they're over here at irrational where they just don't really make sense at the moment. Okay, and you cannot be both. A number cannot be rational and irrational at the same time. Okay, so we added some examples to this the other day, but I'm going to put a few more examples on here. I want you to tell me where, if I were to add the number 45 to this list, where should I put 45? Can anybody tell me? Go ahead, Brinley.
Natural number, whole number, integer, and rational number.
Good. That is all of these. Okay? So remember, as soon as you say a number is a natural number, it's everything else above it. Okay? How about 0.2? Where would you put that? Where does 0.2 go? Where would I add that number? Go ahead, Ethan.
Just an irrational number column.
Absolutely. That is only a rational number because it's a terminating decimal. Terminating means it stops. So that goes there. Okay? How about the square root of 2? Where might I put the square root of 2? Now, if we can do that square root in our head, it would go one place. But if we can't, it goes another place. So where might that go? Okay, Brinley, go ahead.
Irrational number?
Yeah. Square root of 2 is an irrational number, along with numbers like pi. Okay? The square root of 2 is not one that I can easily figure out in my head, so it belongs in the irrational column. Okay? How about negative 15? Where would I put negative 15? Where would that number go? Ethan, go ahead.
Rational number and integer.
Good. It's a rational and it's an integer. It goes in both of those. Okay. It cannot go in the whole numbers because it says no negatives. Natural numbers say no negatives. So again, any of this you want to write down is going to be super helpful. Okay. Now, we're going to, kind of like we did the other day, we're going to play the little game of name that number. Okay. And I want you to type into the chat for me this time. Okay. And we're going to use abbreviations. These letters, Q stands for rational number, Z stands for integer, W is whole number, N is natural number, and I is irrational. So when I show you the number, I want you to type into the chat the letters that you think it belongs in. Okay? So here is the first one. 2. Where would that belong? And go ahead and type it in the chat. And you can just type the letters and type all of them that it belongs in. Okay, and most of you are doing a really nice job here. 2 is a natural number. I can naturally count to 2, 1, 2. And as soon as you put it in natural, it's all of the rest of these. Okay, it's a rational number because you can write 2 as a fraction, 2 over 1. Okay, here's the next one. 0.666666666, so it's a repeating decimal. Okay, if it's a repeating decimal, where does it go? Look carefully at your notes. Where do we put repeating decimals? Okay. So some of you said I. That is not correct. Okay, this is a rational number. Okay, you should have had Q. Okay, repeating decimal. Look at your definitions. If I go back to the definitions, okay, a rational number is any number that can be written as a fraction, including terminating and repeating decimals. If it's a repeating decimal, it's a rational number. Okay, so you should have just had rational on that one. All right, here's the next one. Where would this go? -7. Okay, look at your definitions carefully. And it goes in more than one category. Okay, -7 belongs as Z and Q. Okay, it's an integer because it's a nice whole number that's negative. Okay, but it's also a rational number. I could write this as -7 over 1. So I could write it as a fraction. Okay, let's try another one. 3.65829821, etc., etc. This is not a nice number. It's a big, long decimal that does not end, does not repeat. It only goes in one category. Okay, this is actually an irrational number. Okay, this is irrational. It's irrational because I'm going to go back and look at the definition. The definition of irrational says non-terminating and non-repeating. Okay, so essentially there's no pattern. This number does not have a pattern to it, so it goes in irrational. Okay, rational has to have a pattern. So if you said Q, that would have been wrong. Okay. All right, here's the next one. 0.12 repeating. So it's a repeating decimal. Where do repeating decimals go? Again, look carefully at your definitions. Where would you put a repeating decimal? Okay, and this is a rational number only. Okay, repeating decimals are rational. Again, look at your definitions. In the definitions, rational number is repeating decimals. Okay? All right, the next one. 1/8. Where would you put the number 1/8? Okay, so it's a fraction, and any number that can be written as a fraction is a rational number. And it's only rational. Okay, again, go back and look at your definitions. Because this is a fraction, if I go back to the definitions, in natural, whole, and integer, it says no fractions or decimals. So the only place that it fits is a rational number. Okay. All right, here's the next one. 0.5. Okay, that's a nice decimal. It comes to an end. Where would you put 0.5? Okay, so look at your definitions again. It's a decimal. Can this be a natural number if it's a decimal? We don't normally count. It's not natural to count to 0.5. That means it can't be a whole number also because it's got a decimal. Integers do not have decimals, so it can't be an integer. That means it's a rational number, okay, because it's a terminating decimal. It's a rational number only. Okay, here's the next one, 12/3. Now, sometimes you have to be careful with fractions. You have to look if you can simplify them. 12/3 does simplify to 4. So where would you put that? Okay, lots of you are doing a really good job here. It's natural, it's whole, it's an integer, and it's rational. Okay, it fits in all of those categories because I can naturally count to 4. 1, 2, 3, 4. And if it's natural, remember it's everything above that. Okay, got just a few more. -13, where would you put that one? -13. And it goes in more than one category. Okay, I'm seeing a lot of people answering in the chat, but there are some people that I have not seen put a single answer in the chat yet. Okay, so I'm not even sure if you're there. Because some of you don't have your camera on your face either, so I can't see you. Like Travis, Austin, I can't see you guys. I need to know if you're there. Thank you. Okay. All right, so this 13, I would not naturally count there, so it is not natural. It's not a whole number because whole numbers are not negative. However, it is an integer. And as soon as I check mark something on this side, it's everything above it. So it's integer and rational. I could write that as a fraction. Okay. All right, here's the next one. 0. Where do you put 0? Okay, so I want to remind you that it goes in more than one category. Okay, 0 is not a natural number. We do not naturally count to 0. However, it is a whole number, and as soon as I check whole, it's everything above it. So it's a whole, it's an integer, and it's rational. Now, some of you might be thinking, how do you write 0 as a fraction? Okay, 0 can be written as a fraction in lots of ways. 0 over 2, it's a fraction. 0 over 7, 0 over 5. These all equal 0 yet, okay? So that means they're written as fractions. They are rational numbers. Okay, how about 7.222222222? It's a repeating decimal. Where would you put the repeating decimal? Okay, nice job. A repeating decimal is a rational number only. Okay, it is not an integer. Integers cannot have decimals. Okay, how about, let's go to this one. The square root of 36. Where would you put that? The square root of 36. Now remember, the square root of 36 equals 6. So be careful. Some of you immediately wanted to say I, but the square root of 36 is 6. So then where would it go? And it goes in more than one category. Okay, 6, I can naturally count to 6. 1, 2, 3, 4, 5, 6. So it's natural. And remember, if it's natural, it's everything above that. It's whole, it's an integer, and it's rational. Okay, last one. Pi. Where would you put pi? And we've talked about this one a few times already. Pi is not a nice decimal at all. It's 3.141596, blah, 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 blah. It keeps going on. It's really quite an ugly decimal. It doesn't make sense. Pi is an irrational number. Okay? You should have said I. Pi goes under I. Okay, so now I would like